So in this video, we are going to see the part 2 of the last topic we have discussed about the vectors, how it has been represented, what are the vectors operations, and how the norms and magnitude, that is the length, and up to that we have been discussed. And this is the part 2 of that video. All these are in the linear algebra in ML. Okay, so now we are going to discuss about the norms and magnitudes and linear uh, things and all these things we will be discussing in the upcoming slides. So what is norms and what is magnitudes? It is nothing but how long, how the length or the size, that is nothing but the norms. Okay, so norms and magnitudes are fundamental concept in ML and data science, especially working on vectors. So this is working with the vectors, matrices, distance, gradients, and optimization. Okay, so what is norms? What is magnitude? It is nothing but the length. Norms or magnitude or length or size, all the same meaning. Okay, so what is this? What do you understand from the norms or magnitude? That is, if you're walking from your home to a park, and it will be that if you're walking to that place, it will show a direction shown by an arrow called a vector. Okay, so that is the direction from the home you are walking to the park. Okay, it shows a direction, shows an arrow. So the length, that length we are going to know by the norm. Okay, for example, if you are moving three steps, so suppose the vector is 3 comma 4, and that 3 is that steps towards right and 4 is steps towards up, then how the length will be calculated? The length will be calculated like this. How? Let us see in the next slide. Okay, so see here how the length is been calculated. If this is a vector, v is equal to x, v vector x comma y. So these are the values 3 comma 4 something else, then this will be applied to this. Okay, suppose the value is minus or something, we will be discussing in the upcoming slides if we have time. So okay, so if we are applying the values of x and comma y, then it will be applied, and the vector, the value will be, we can get. Okay, if the value have three components, the vector has three components, then the formula will be like this: x squared plus y squared plus z squared, the whole root. Okay, so see this is how the length is been calculated. If 3 comma 4, then the x comma y, x squared plus y squared has been applied here, and the length is been calculated like this. Okay, now the length is 5. Next, angle between the vectors. So it is nothing but we are going to know about the angle between vectors now. So before that, we want like see that vector is equal to direction plus distance. Okay, vector is equal to direction plus distance. Now we have calculated what? We have calculated the length. Okay. Okay, see, let's say you are walking from your home. When you are at your home, that value will be 0 comma 0, and you are walking into 3 steps and 4 step up, means then the vector will be showing you path like 3 comma 4. Okay, now we have moved from our home to some place, and now we want to know how far we have walked. So that is the length we have calculated here. Okay, so that's why that's how we have applied the formula like this, and we have calculated the value 5. Okay, so next one, angle between vectors. So angle between vectors tells us how much one arrow turns to become another arrow, or how different two directions are from each other. So see this. If I go like this straight and straight east, and my friend goes to straight north, then that the shape will be like L. Okay, so this kind of shape will give you 90-degree answer. Okay, so that degree is nothing, it is angle between vectors. So see, if the value is, if walking in the same direction, both are walking in the same direction, then it will be 0 degree. Turning in the corner 90 degree. Walking in opposite means 180 degree. Okay, now see how to find the angle between two vectors. We are for finding the angle between two vectors, we are using formula cos theta equal to a vector in dot b vector by this all these values. Okay, so we are first we have to find the dot product, and then we are going to apply this, and then we are finding the theta value, that is the angle between them. Okay, so for example, if the value f a is 1 comma 0 and b is 0 comma 1, and we are finding the dot product, how will be dot product? We will be multiply and then add. Okay, the value will be 0. So the above value, that is the this value will be now 0, and we are going to find the below values. Okay, so that value is how we are applying. That is the length. This is the length. We are going to find it, that length will be like 1 squared plus 0 squared. Okay, that is 1. And next b value we are going to find out, that b is 0 comma 1, and we have applied that value inside here. Here a, for a we are applying 1 comma 0 here, and the value is 1, and for b we are applying, and that value is 1, and both we will be applying in the formula. Okay, 0 divided by 1 into 1, that is 0. If this value is 0, then it is 90 degree. Okay. Okay, so again I'm showing that the length of the vector, the formulas and all these things. Okay, okay, the for now we have found that cos theta is equal to 0, that is the value is the value is 90 degree. Next we're going to learn about the projections. Projections is nothing but how much one arrow is in the direction of another one arrow. That is, if you are throwing a ball to a mountain, that the ball will be or go on to the mountain, but the mountain is in this kind of shape, not straight, not flat, but it will be like a kind of shape, that means the ball is going on the mountain, on over the mountain, and the shadow, that shadow we are going to calculate what is the direction, how much length, and like that. Okay, so this is like this, the ball will be going in the that direction. Okay, next the formulas. This is also having formulas, and the projections having two kinds of formulas for scalar projections and vector projections. Okay, two both having formulas. So this is the scalar projections formula. So projection is nothing but how much one vector lies on the direction of another vector. This is nothing. What I said, that is the example just to understand, but the definition is this. Okay, and the vector projection onto B. That is, this is the formula of the B. In the scalar projections, it will be number, and in the vector projection, it will be vector. Okay. For example, we are applying the values. For suppose A is 3 comma 4, and B is 1 comma 0. Okay. Then we will be multiplying the dot function will be applied in the above part, and below the b value, that the formula of b is been applied, and then b value here 1 comma 0 is applied, and the final value is 3 comma 0. Now that is the value 3 comma 0. Okay, so this is scalar projection, and this formula is here. This is the vector projection, and the formula is here. Okay, I have discussed how working out the example. That's what is shown here. Okay, next one we are discussing is next is linear combination. Linear combination is nothing but a linear combination of vectors means adding together multiple of vectors. That is, multiple vectors are being added together is called as linear combinations. Okay, that is you are taking some vectors multiplying each by a number and then add them together. Okay, that is what happening in linear combination. And for vectors, it will be like this, and for scalars, that is numbers, means it will be like this. And for both, we are combining here, and that is how the final looks like is a1 v1 plus a2 v2 plus etc etc a and vn. Okay, so if two values are like this, a1 equal to 2 and a2 is equal to minus 1, v1 and v2 values are here. And the linear combinations, both combinations will be like this: 2 into 1 comma 2 plus, so that is dot, plus minus 1 dot 3 comma minus 1. Then the formula, then the final answer will be minus 1 comma 5. This is the combination, linear combination final answer. So where it has been used, it is used in computer graphics, machine learning, vector spaces, data transformations, etc. Okay, so these are the vector and all the vector operations, vector norms, all these things are discussed in these two videos.